Hello and greetings to everyone. We will continue from where we ended last time with the correction of the following exercises for application. We are going to take down solution. Question 1 says, change the following numbers to base 2. For A, we have the number 19. For us to change the number 19 to base 2, we are going to make use of the process of repeated division. First column, we have the number 2. For the second column, we have 19. And for the third column, we have the remainders. 19 divided by 2 gives us 9, remainder 1. We bring down 2. 9 divided by 2 gives us 4, remainder 1. Bring down 2. 4 divided by 2 gives us 2, remainder 0. We bring down 2. 2 divided by 2 gives us 1, remainder 0. We bring down 2. 1 divided by 2 gives us 0, remainder 1. Then we copy the remainders from bottom to top. Therefore, 19 in base 2 is simply equal to 1, 0, 0, 1, 1. And we must precise the base 2. Next, for B, we have the number 59. We are going to make use of repeated division. For the first column, we are going to have the number 2. And for the second, we have 59. Then for the third column, we have the remainders. We are going to take 59 divided by 2. 59 divided by 2 gives us 29, remainder 1. Next, we are going to divide the number 29 by 2, which gives us 14, remainder 1. Next, we are going to divide 14 by 2, gives us 7, remainder 0. We bring down 2. 7 divided by 2 gives us 3, remainder 1. We bring down 2. 3 divided by 2 gives us 1, remainder 1. We bring down 2. 1 divided by 2 gives us 0, remainder 1. The whole number part will be 0, the remainder will be 1. Then we copy from bottom to top. Therefore, number 59 in base 2 is simply equal to 1, 1, 1, 0, 1, 1. Then we must precise the base, because if you don't put the base, that means this number is in base 10. You must put the base to be underline our answer. Now we go to C. For C, we have the number 104. We have to divide the number. We have to make use of repeated division. So for the first column, we have 2. The second column, we have the number 104. And for the last column, we have the remainder. Take 104 divided by 2, it gives us 52, remainder 0. We bring down 2. Next, we have to divide 52 by 2, which gives us 26, remainder 0. We bring down 2. 26 divided by 2 gives us 13, remainder 0. We bring down 2. 13 divided by 2 gives us 6, remainder 1. We bring down 2. 6 divided by 2 gives us 3, remainder 0. We bring down 2. 3 divided by 2 gives us 1, remainder 1. We bring down 2. 1 divided by 2 gives us the whole number part of 0, the remainder of 1. We copy from bottom to top. We conclude, therefore, the number 104 in base 2 is simply equal to 1 1 0 1 0 0 0 0 0 0. Then we must precise the base in base 2. We are done with C. Next we go now to D. For D we have the number 423. First column we have 2. Next we have 423. Last column we have the remainders. The next thing we have to do is we have to divide the number 423 by 2, and this will give us 211, remainder 1. Bring down 2. Next we divide 211 by 2. This will give us 105, remainder 1. Bring down 2. We have to divide the number 105 by 2. This will simply give us 52, remainder 1. Bring down 2. We have to divide the number 52 by 2. This will simply give us 26. Bring down 2. 26 remainder 0. 26 divided by 2 will simply give us 13, remainder 0. Bring down 2. 13 divided by 2 will simply give us 6, remainder 1. Bring down 2. 6 divided by 2 will give us 3, remainder 0. Bring down 2. 3 divided by 2 will give us 1, remainder 1. We bring down 2. 1 divided by 2 will give us whole number part of 0 and a remainder of 1. And we can conclude, therefore, we're going to put the conclusion down here. Therefore, the number 423 in base 2 is simply equal to, we have to copy from bottom to top. Start from last remainder to the first. This will give us 1 1 0 1 1 1 0 1, 2 zeros 0 0 1 1 1. We must put the base. The new base is 2. And we are done. We underline the answer. Now we are going to question 2. Question 2 says change the following numbers to base 10. So here we have the first number, which is 1 with 3 zeros in base 2. For us to change this number to base 10, we are simply going to expand this number in powers of the base 2. So this will give us 1 times 2 to the power 1, 2, 3. All the other digits after 1, they are 0, so we are going to ignore them. This will simply be equal to 1 times, we know 2 to the power 3 is simply 2 times 2 times 2, which is simply equal to 1 times 2 remains 2, 2 times 2 gives us 4, 4 times 2 gives us 8. We are done with A. For B, we have the number 1 with 4 zeros, 1 in base 2. This will give us 1 times 2 to the power 1, 2, 3, 4, 5. Plus the other digits are zeros, so we are going to ignore them. Move to the last digit, which is 1 times 2 to the power. After 1, there's no digit, so 2 to the power 0. This will give us 1 times 2 to the power 5 is simply 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Plus 1 times 2 to the power 0 is simply 1. This will be equal to 1 times 2 remains 2. 2 times 2 gives 4. 4 times 2 gives 8. 8 times 2 gives 16. 16 times 2 gives us 32. Plus 1 times 1 gives us 1. So if you add 32 plus 1, it gives us 33 to the base 10. Next for C, we have the number 1, 1, 1, 1, 1 in base 2. This will simply be equal to 1 times 2 to the power 1, 2, 3, 4. 4 plus the next 1 times 2 to the power 3 plus 1 times 2 to the power 2 plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. This will simply give us 1 times 2 times 2 times 2 times 2 plus 1 times 2 times 2 times 2, 2 to the power 3 plus 1 times 2 times 2 plus 1 times 2 to the power 1 is simply 2 plus 1 times 2 to the power 0 is 1. This will give us 1 times 2 is 2 times 2 4 times 2 8 times 2 gives us 16 plus 1 times 2 2 times 2 4 times 2 8 plus 1 times 2 gives us 2 times 2 gives 4 plus 1 times 2 remains 2 plus 1 times 1 1. This will give us 16 plus 8 gives us 24. 24 plus 4 gives us 28 plus 2 it gives us 30 plus 1 gives us 31. Next, now we go to D. For D, we have the number 1, 1, 1, 0, 0, 1, 0, 1 base 2. This will simply give us 1 times 2 to the power 1, 2, 3, 4, 5, 6, 7 plus 1 times 1, 2, 1 times 2 raised to the power 1, 2, 3, 4, 5, 6 plus the next 1 times 2 raised to the power 1, 2, 3, 4, 5. The next digits are zeros, we are going to ignore them. We move to 1 plus 1 times, this is 1 times 2 to the power 1, 2 plus the next digit is 0. We are going to ignore it. Move now to the last digit plus 1 times 2 to the power 0. This will simply be equal to 1 times 2. 2 raised to the power 7 is simply 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7 plus 1 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times 2 plus 1 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 plus 1 times 2 times 2. 2 raised to the power 2 is simply 2 times 2 plus 1 times 2 to the power 0 is simply 1. This will be equal to 1 times 2 gives us 2 times 2 4 times 2 gives 8 times 2 gives 16 times 2 gives us 32 times 2 gives us the number 64 times 2 it gives us the number 128 plus this will give us 2 times 2 gives 4 times 2 gives 8 times 2 gives 16 times 2 gives us 32 times 2 gives us 64 plus 2 times 2 4 times 2 8 times 2 16 times 2 32 plus 2 times 2 gives us 4, then plus 1 times 1 which is 1. This will give us 128 plus 64 gives us 192 plus 32 it gives us 224 and plus 4 it gives us 228 plus 1 it gives us 229. We are done with question D. We are done with the exercises for application. Next, now we are going to move to 3I, which is this 5. 3I base 5. Under this base 5, we are just going to see how to handle other bases. That means like base 6 or base 4, base 7 or base 8. Let's write this down in base 5. Counting is done in groupings of 5. In base 5 again, base 5, we make use of 5 digits. That is, these are the 5 digits we make use of in base 5. We make use of the digits 0, 1, 2, 3, and lastly 4. That means all numbers in base 5 are built up using these 5 digits. Next, we write a number in base. Write a number in base 5 by writing the number. That means the number which is formed by making use of these 5 digits, by writing the number and a subscript. 5. Subscript 5. E.g., let's take example given. The number 324 in base 5 be written as such with a subscript 5 at the end. That means this number is in base 5. The number 3214 in base 5 will be written with a subscript 5. These are examples. Next, we're going to take the hidden convention from base 5 to base 10. The convention from base 5 to base 10 is similar to the convention from base 2 to base 10. That means we simply expand the number in powers of 5. Write this down: convention from base 5 or any other base. When we talk of any other base, that means the base can be base 3 or base 4 or base 6. Any other base to base 10 is similar, similar to convention from base 2 to base 10. We convert a number given in any base given in any base to base 10 by expansion of the number in powers of the given base. Let's take a note. Let's note this down. It's very important. Note: for a not equal to 0, that means a is a number, but a should be different from 0. We have a to the power 0 is equal to 1. We have a to the power 1 is equal to a. We have a to the power n is equal to a times 3 dots times a. We multiply a by itself n times. This is what it means. E.g., we take for example the first one, 5 to the power 0 is equal to 1, 6 to the power 0 is equal to 1, 7 to the power 0 is equal to 1, and so on. But 0 to the power 0 does not exist. 2i, 5 to the power 1 is the same as 5, 5 to the power 6 to the power 1 is equal to 6, 7 to the power 1 is equal to 7, and so on. We take 3, 5 to the power 3, for example, is this as 5 times 5 times 5. Multiply 5 by itself 3 times. This will give us 125. Take 6 to the power 4. This has 6 times 6 times 6 times 6, which is equal to 1296, and so on. Now let's take an example on how we can convert a number given in any base to base 10. Let's take example. Convert the following numbers. Convert following numbers to base 10. First one, A, we have the number 3021, base 4. B, we have the number 324, base 5. C, we have the number 123, base 6. Next, we are going to take down solution. A, if we take A, we have the number 3021 base 4. For us to convert this number to base 10, we are simply going to expand this number in powers of 4. This will give us 3 times 4, the base is 4. 4 will be raised to the power 1, 2, 3. Plus the next digit is 0 times 4 is the base. 4 will be raised to the power 1, 2. Plus the next digit is 2 times 4 raised to the power. After 2, we have just one digit, 4 raised to the power 1. Plus 1 times 4 means after 1 there is no digit, 4 raised to the power 0. This will give us 3 times 4 to the power 3 is simply 4 times 4 times 4. Plus 0 times 4 to the power 2 is 4 times 4. Plus 2 times 4 raised to the power 1 is simply 4. Plus 1 times 4 to the power 0 is 1. This will give us 3 times 4 gives us the number 12. 12 times 4 gives us the number 48. 48 times 4 gives us the number 192 plus 0 times 4 gives 0 times 4 remains 0 plus 2 times 4 gives us 8 plus 1 times 1 gives us 1. The next step now we are to add. We have to add these numbers. 192 plus 0 remains 192. 192 plus 8 gives us 200 plus 1. We're going to obtain 201 in base 10. We go now to B. For B, we have the number 324 in base 5. This will give us 3 times 5 raised to the power 1, 2. Plus the next we have 2. The next is 2 times 5 raised to the power. After 2, we have just 1 digit. Plus 4 times 5 raised to the power 0. This will give us 3 times 5 times 5 plus 2 times 5 raised to the power 1 is simply 5 plus 4 times 5 raised to the power 0 is 1. This will simply give us 3 times 5 is 15. We multiply 15 by 5. This will give us 25 by 5. We carry 2. 5 times 1 remains 5 plus 2 gives us 75 plus 2 times 5 gives us 10 plus 4 times 1 gives us 4. This will give us 75 plus 10 is equal to 85. 85 plus 4 gives us 89. Next we go to C, question C. For C we have the number 1, 2, 3 in base 6. This will give us 1 times the base is 6 raised to the power 1, 2 plus 2 times 6 raised to power 1 plus 3 times 6 raised to the power 0. This will simply be equal to 1 times 6 plus 2 times 6. 6 to the power 1 is 6 plus 3 times 6 to the power 0 is 1. This will give us 1 times 6 remains 6. 6 times 6 gives us 36 plus 2 times 6 gives us 12 plus 3 times 1 remains 3. Next, if we add 36 plus 12 plus 3, 6 plus 2 gives us 8. 8 plus 3 gives us 11. We write down 1, we carry 1. 3 plus 1 gives us 4 plus 1. This will give us 51. And we are done. Next, we are going to take down the hidden convention from base 10 to convention from base 10 to base 5. Convention from base 10 to base 5 is similar to convention from base 10 to base 2. So we are going to make use of the process of repeated division by number 5. In this case, let's write this down. To convert a binary number, that means a number in base 10 to base 5 or any other base. When we talk of any other base, that means base 6, base 4. We carry out repeated division of the number. When we talk of the number, that means the binary number of the binary number by the base 5 or by the given base in a case where the base is different from 5, or by the given base. By the given base y recording while recording the remainders. Record the remainders. Next, now the solution means the number in the given base, in the required base. The solution is the remainders. Copy it. Starting from the last remainder. From the last remainder to the first remainder. Copy the remainders in that order. First remainder. Let's take example. Example goes, change the following binary numbers. Change the following binary numbers. Change the following binary numbers to the stated basis. So A, we have to change the binary number 56 to base 4. B, we have to change the binary number 457 to base 5. C, we have to change the binary number 753 to base 6. Next, we are going to take now solution. We answer the questions. Solution. First one, question A. We add for 56 to a new base of 4. For us to convert 56 to a new base of 4, we are going to make use of repeated division. For the first column, we have the new base, which is 4. The second column, we have the binary number 56. And for the last column, we have the remainder. We are going to divide 56 by 4. 56 divided by 4 gives us 14, remainder 0. Next, we have to divide 14 by 4. 14 divided by 4 gives us 3, remainder 2, bring down 4. Next, we divide 3 by 4. It gives us a whole number part of 0. Remainder will simply be 3. 3 is less than 4. Therefore, we conclude 56 will simply be equal to, we're going to copy the remainders from bottom to top, 3, 2, 0. Then we must precise the base to a new base of 4. This is the answer. Question B says we should change the number 457 to base 5. We're still going to make use of repeated division. For the first column, we have 5. The second, we have the number 457. The next, we have the remainders. We divide 457 by 5, it gives us 91. Remainder 2, bring down 5. 91 divided by 5 gives us 18. Remainder 1, bring down 5. 18 divided by 5 gives us 3, remainder 3. Bring down 5. 3 is less than 5. 3 divided by 5 gives us a whole number part of 0 and a remainder of 3. So we copy from bottom to top. Therefore, the number 457 in base 5 is simply equal to 3, 3, 1, 2. We put the base 5. Next, we go to question C, which says we should change the number 753 to base 6. Yes, still going to make use of repeated division. For the first column, we have 6, which is the new base. Second, we have the number 753. And for the third column, we have the remainder. We divide. 753 divided by 6 gives us 125. Remainder 3. We bring down 6. 125 divided by 6 gives us 20. Remainder 5. We bring down 6. 20 divided by 6 gives us 3. Remainder 2. We bring down 6. 3 is less than 6. We divide 3 by 6, the whole number part will be 0, and the remainder will simply be 3. We copy from bottom to top. Therefore, the number 753 in base 6 is simply equal to 3, 2, 5, 3. We must precise the base. Base is 6. That's why subscript 6 has been written beside. Next, now we are going to end by taking down exercises for application on this. The first question goes, which of the following following numbers is not in base 5? For E, we have the number 213. For B, we have the number 1503. For C, we have the number 4270. For D, we have the number 26. E, we have the number 5. And for F, we have the number 225251. Question 2 says change the following numbers to base 10. Here we have the number 242 in base 5. B, we have the number 1432 in base 5. C, we have the number 1450 in base 6. And lastly, D, we have the number 7402 in base 8. We take now the last question. Question 3. Question 3 says change the following numbers from base 10 to the stated base. Here we have the number 256 to base 5. Here we have the number 931 to base 6. For C we have the number 777 to base let's take base 7. Lastly for D, number 890, which is 8, 890 to base 8. We are done with the exercises. Do well to go through the exercises. Then in the next video, we are going to correct the exercises. Then we will treat how to change from one base to another. That means changing, for example, from base 5 to base 4, or changing from base 2 to base 8, or changing from base 8 to base 9. Then after that, we are going to treat arithmetic operations in a given base, that is addition, subtraction, multiplication, and division of numbers in a given base. Do well to like the video, share, and subscribe to this channel. Thank you very much for watching.